right, tonight we're going to do two sections, 11.6 and 11.7. We're going to focus on simplifying these radical expressions, and a radical is just a square root. So this is called a radical sign right here. So just like last night, any equation with a square root of x is a radical expression. So if you have something like the square root of x, what is it? That's either the positive or negative x. So remember how we did that negative square root of, I think it was 400, and I said really, if we take this negative out front, it's plus or minus 20. So really it's plus or minus 20 no matter what. So if you always just take the absolute value of the square root, you can ensure that you'll get the right sign. So using this method, this would actually be negative 20 as your answer. So we're basically going to focus on the positives. So the square root of x cubed, basically nothing more than an x can be left under the square root. Everything else is simplifiable. So I'm going to rewrite x cubed as the square root of x squared times the square root of x. And the square root of x squared is just x. So this is x root x. That's your answer. So the square root of x to the fourth, that's the square root of x squared times the square root of x squared. So that would be x times x. So the square root of x to the fourth is x squared. The square root of x to the fifth, so an x squared comes out of a square root perfectly. So this would be x times the square root of x. So the square root of x to the fifth simplifies to x squared root x. The square root of x to the sixth, since it's an even exponent, there's going to be nothing left under the square root. So this is x times x, which is x cubed. And the square root of x to the seventh, since it's an odd exponent, there will be a 1x left under. Because remember, x squared, and x multiply to give you x to the seventh. So we have x times times the square root of x. So this would be x cubed root x. Another way to think about this is that the square root of x is the same exact thing as x to the 1/2. So if you think about the square root of x to the 6th being x to the 6th to the 1/2, you get x cubed. If you think about that with an odd number, like x to the 7th, you get x to the 3.5. So that's how you know it's x cubed. And then the x to the 1/2 is the square root of x. So either method will work. In the first problem here, this is perfect squares. So this factors into x plus 4 squared. So the square root and a squared term cancel each other out. So that would just be x plus 4. You can't take the square root with plus and minuses, so you'd have to have it where it's linked together, or you would not be able to do it. Something like this, you could separate the square root, or if 9 divided by 49 simplified, you could do that as well. So the square root of 9 is just 3, and the square root of 49 is 7, so we can just leave it just like that. And then 3 over 25 simplifies to 1 over, 3 over 75 simplifies to 1 over 25. So we could simplify that right away. So that's the same exact thing as the square root of 1 over the square root of 25. So that's just going to be our 1/5. All right, so square root of 3 times square root of 12. Instead of multiplying it together, let's just break this down. 12 is 3 times 4. So the square root of 4 is 2. The square root of 3 times the square root of 3 is 3. 2 square roots cancel each other out. You can think of that as the square root of 9, which is 3, or you can just think of it as the 2 square roots cancel each other out and you get a 3. So 3 times 2 means you would be left with the answer of 6. Because 2 square roots next to each other means you multiply. So 24, when I think of that, I think of 4 times 6. 6 can be broken down into 2 and 3, but neither of them have a perfect square root. So we can just leave that as 2 root 6. That would be the simplest form for that one. All right, 8 is 4 times 2. And x squared, you can take an x out. So we have a 2, a root 2, and an x. So our simplest form answer for that, you want everything that's not in a square root out front and everything under the square root in the back. All right, 50 is 25 times 2, and x cubed is x squared times x. So we have 5 root 2 x root x. So this would simplify to 5x times root 2x. All right, we're getting a little bit more difficult. You can't have a square root left in the denominator, so if you do, you need to make sure you get rid of that. We could just break this up like so. The square root of 4 is 2, so that's wonderful. So that's our answer. In this one, before you go dividing, or square rooting, you can divide. M cubed over m is m squared. We're canceling one of the m's out. So this is really the square root of m squared over the square root of 9, which is m over 3. All right. Square root of 108. So we're thinking of what numbers multiply to give you 108. 9 times 12. I'll write this down here. And 12 can be broken down again. So that's 4 times 3. So this is really 3 times 2 times the square root of 3. So the top simplifies to 6 root 3. The bottom, the square root of 25, is just 5. And nothing can cancel, so that would be our answer. In the next problem, the 10 over the 100 can cancel, so we have 1 over 10. Let's go ahead and do that, because I want to show you what to do if you have a square root in the bottom. In this case, it would be better to not do that so that you don't have a square root left in the bottom, but we will just keep going and you'll understand in a minute. So we have the square root of x squared times the square root of x all over the square root of 10. So this is really x square root x over the square root of 10. Now, remember what I said about a square root in the denominator being improper. So to get rid of that square root, we would have to multiply it by itself, because the square root times itself cancels. But what you do to the bottom, you have to do to the top to keep the balance. Remember, this fraction is kind of like a teeter-totter, and it has to remain balanced. So the square root of 10 times the square root of 10 is just the number 10, because this multiplies to give you the square root of 100, which is 10. In the numerator, you have your x, and under the square root, you're left with 10x. So this is our most simple version of this. If you did not initially reduce, you would get that more quickly and easily, but probably you're going to start reducing if you can. So if you do reduce and you get a square root in the denominator, do not forget you cannot leave it that way. So in this one, we have the square root of 20, which is square root of 4 times the square root of 5. So the numerator simplifies to 2 root 5. The denominator, the square root of 49, is perfect. The square root of x to the 4th is also perfect. So we have 7 times x times x. So the denominator is 7x squared. Nothing cancels, so you're done. Isn't this fun? All right, now we're going to add and subtract. Just like adding and subtracting fractions, you have to have like terms. This is showing that 2 root 5 plus 4 root 5 is just the answer of 6 root 5. You can add them because they both have a root 5. The square root, the radical, is like your x value. All right, 9 root 3 minus 4 root 3, we can totally put those together. 9 minus 4 is 5, so the answer here is 5 root 3. 6 root x plus 8 root y, we cannot put those together. So this is actually our answer. We don't need to do a thing. 1 root m minus 7 root m is negative 6 root m. We can put them together because they both have a root m. The xy terms we can put together, so we have 9 of them and 2 of them. So that's 11 root xy. And then we can't forget about our 2 root y that's hanging out there. All right, so now these do not look like, but they may be like terms. We have to put them in simplest form before we do anything. So 45 is 9 times 5. So this is really 3 root 5. And 20, I think of 4 times 5. So this is really 2 root 5. We have that minus in the middle, so let's bring the minus on down. So this is really 3 root 5 minus 2 root 5, and that's 1 root 5. So we can put those together because they do simplify in simplest form to have like radical signs. 75 is 25 times 3. Let's keep bringing our 9 down so we don't forget it. So this is really 9 times 5 times root 3. So that'd be 45 root 3. Plus 50 is 25 times 2. And let's bring that 2 down. So this is really 2 times 5 times root 2. So this is 10 root 2. We cannot put those together because a root 3 and a root 2 are not like terms. So we're done. And then root 75, we already know simplifies into 5 root 3 because we just did it right here. So this is 5 root 3, and that y is not coming out. The next term, 27, 9 goes into that. So 9 times 3 times y, and don't forget your 2 here. So this is really 2 times 3 root 3y. So this is 6 root 3y. Well, these two can go together, so let's make sure we do that. Let's actually just do that. So negative 1 root 3y. And now we've got our 48y. Hopefully you can see that that's 4 times 12 times y. And if you know 16 goes into it, go ahead and do that. If you don't, just make sure you know that 12 is 4 times 3. So this is really 2 times root 3y. So this gives us 4 root 3y. So this letter C, every single one of them is a root 3y, so we can put them all together, and we'll get 3 root 3y as our final answer. And that is it. Have a great night.